Hello and a very warm welcome to another HAKOM webinar. I'm Stefan Komornyik, co-founder and managing partner at HAKOM Time Series. Like always, all our live webinars are recorded and uploaded to our YouTube channel. You will receive a direct link along with a follow-up email right afterwards. Check out our YouTube channel for more in-depth information on our technology. Please hit the subscribe button to stay up to date on Time Series. Last time we talked about co-pilots for time series data in the energy sector. We gave some insights into Microsoft's strategy and shared our vision of a co-pilot for time series data. Please check out the recordings on our YouTube channel to see how PowerTSM developers can make use of LLMs already today. This time we want to talk about yet another relevant topic: connectivity. Did you ever end up in an energy data jungle? That's how we call the sometimes messy situation regarding data environments of energy companies. There are numerous sources of relevant data, different ways to store it, and typically no unified way to process data in various applications. According to the recent 2025 Connectivity Benchmark report done by MuleSoft, IT leaders and decision makers report an increase in applications in use from 762 in 2023 to 1,103 in 2024. Along goes an increase of labor costs in IT from 10.5 million euro to 16.9 million euro in the same years. So, more apps and more labor costs? How can this be met? Right, it's all about connectivity. And to keep a long story short, what we want to talk about today is how to connect the unconnected. We believe that the best way to connect is via API, and ideally via standardized and purpose-built APIs where no trade-offs have been made. Let us have a closer look at this topic to ask some very specific questions. How can we close the gap between OT and IT, a typical challenge of today's modern energy markets? How should interfaces between systems and their data look like? And what are our expectations and visions for connecting time series coming from different sources? So, here's the agenda for today. We will get insights into an innovative system architecture that enables remote meter readings for district heating and water network operators to obtain relevant sensor data to optimize their network performance. We will discuss how this flexible architecture can further enable complex two-way processes like electricity feed-in regulation from multiple and diverse solar PV systems to ensure grid stability. And finally, we will show how PowerTSM users can easily connect to such applications available at the new PowerTSM Store. With us is Reinier, product manager at Specific Group. Specific Group was founded in Austria in 1998. With over 500 employees in 10 countries, they have become a leading IT service provider, also offering tailored product solutions for vertical markets such as energy. Reinier is an experienced product manager, applying his extensive knowledge in IoT embedded systems for energy services. Sharing his experience, he will give us insights into challenges and opportunities creating powerful end-to-end solutions connecting OT and IT systems in modern energy markets. Once again back is the one and only Thomas Hasleder as our second panelist. Being my co-founder and managing partner at HAKOM Time Series, he is responsible for product management of the PowerTSM Time Series technology. He will share his insights on how energy companies can benefit from our new PowerTSM Store to break down barriers between different data silos and to connect the unconnected as easy as ABC. So, let's meet the panelists and get connected. Hi again, and welcome to the next HAKOM webinar here from Vienna. Hi Reinier. Hi.
Hi Stefan.
And Thomas, just in time.
Hi, hello.
We're really looking forward to this one today. And again, thank you once more for joining, because today's topic was actually just suggested already last year by one of our cloud service customers. They said, why don't you open up your platform for any interested party to publish their service? And the idea of the PowerTSM Store and this webinar actually was born. So as you can see, we're happy to receive suggestions for interesting webinar topics, and we're willing to take them up. During the webinar, like always, I ask you to use the Q&A function. I'm sure you know how that works. In our session at the end, We will again try to answer everything you drop in. So please challenge us. We will do our best. Before starting with our use case, I would like to share some general thoughts with you. In the intro, I said that we should connect the unconnected. The question obviously is, why should we do that? And the reason for this is very simple. Looking at this study by MuleSoft, we get insights into the thoughts of IT leaders of global companies with more than 1,000 headcount. They were asked about the challenges to introduce AI. And what they say reveals a relevant fact that needs our attention, even if it's not about AI. Data integration is that big challenge. And as already mentioned, labor costs in IT increased massively in 2024. And with a share of 39%, system integration costs contribute massively to this development. But why is that? The explanation is quite simple. With data being measured basically everywhere in the energy space, the sheer amount of applications increases massively. Namely, in that survey, from more than 760 to more than 1100 as an average. But how can we master this? How can we master this energy data jungle of numerous different sources, storages, and applications? We obviously need to increase efficiency and productivity. Talking about labor costs and availability of specialists, we see a very strong reluctancy of specialists, especially with the younger ones, to work with outdated interfaces and technologies. It simply is not motivating to dig through outdated code of countless point-to-point connections as depicted here. So what can we do actually? And again, the survey gives us the answer. Using APIs, we can boost overall productivity of system integration. And we can increase employee retention and collaboration, thus fostering efficiency and innovation at the same time. So does that mean that building an API for each particular application is good? No, we say no. The answer is to develop purpose-built APIs, each designed for its specific usage. And with us at HAKOM Time Series, our focus is to build the perfect API for integrating time series data. So let's have a look at how to use such APIs in an innovative use case. Reinier, please take over.
Stefan, thanks a lot for the invitation. Looking forward to share all my insights and experiences that we made so far. So I would say the first place to start is, of course, with the use case. Thank you very much. So in the EU, we have the so-called EU Energy Efficiency Directive, which basically states that energy providers should provide the end customers with consumption reports on at least on a monthly basis, with the intention to enable the end customer to optimize their own usage. The problem, however, today is that a lot of this meter readings, which you effectively need to get the consumption, is done manually. This means once a year, somebody would go out and literally read all the meters, and only then the accounting will be done, and then you will get more or less an idea of your consumption for the year. From an energy efficiency point of view, this is of course a little bit too late. So the idea here is that you do this automatically. Now this is of course very good for the energy provider as well and for end customers, because the customer can get this on a much easier basis, and it's a lot less effort for the energy provider. So I have to state here also that the difference between smart meters for electricity and smart meters specifically for water and heating networks is the main point here. And we are not focusing on electricity meters, so we are focusing on heating and water meters. And for this, LoRaWAN is correctly the right technology that we believe. Can you please move to the next slide? So why LoRaWAN? The main issue here is the battery life. The battery life of LoRaWAN sensors can easily last up to 5 to 10 years. And you have an extremely long communication distance, up to 10 kilometers line of sight. And this allows for battery-operated heating and water meters to use energy-efficient technology like LoRaWAN. LoRaWAN is also a mature technology and that has a large ecosystem. Stefan, can you please move on to the next slide, where I will briefly show our architecture. Yes, so of course there's a lot of things going on this architecture, so I will really go through this in a very short space of time. On the top left, you have the heating meters and the water meters, and they basically communicate with gateways, LoRa gateways, and then there is a backhaul interface, which can either be a normal classic wired network or LTE network, and this then ends up into our system. We have a cloud native system, and it is based on Kubernetes. And we have a number of containers running this Kubernetes cluster. And from there, we go to the network server, which is a dependency of ours. In this case, we use ChirpStack. The data then gets exported from ChirpStack to intermediate database. And this is typically Influx database. And currently, we are looking at PowerTSM that we want to integrate here for improved performance and efficiency. This gets processed to the backend. And then again, for your audience, the downstream integrations here are quite interesting here. How do you get the meter readings into the IT systems for billing purposes? So I think this should be more or less clear how the data flows from architecture. Stefan, if you could please move to the next slide. Yes. So what are we actually trying to solve here? The main problem here is that we want to provide an end-to-end solution. So if you think about typical IoT platforms, this is a horizontally oriented platform, and it only brings you to maybe 80% of the solution. And in reality, the utility providers need an end-to-end solution from device deployment, how you manage the entire network, and also all the integrations with the existing systems. But there is no off-the-shelf solution for something like this. And this is where we come in. We try to provide a custom end-to-end solution for the energy providers who are, of course, not software developers. So we made a brief video just to give an introduction to our platform. So Vera, if you could please just show the short video.
Right, so let's do a short overview and introduction of the Tseba platform and what it can do. We have, of course, a dashboard and a landing page for the platform. And here you have an overview of the network. And this gives you a summary of what is currently the main issues in the network. So here we can see the amount of nodes currently in operation, the amount of gateways in operation, if there are any critical alerts open, and also the status of our underlying infrastructure that we're using, such as the LoRa network server, the database, or our integrations. If we look here at the map, we get an overview of all the devices or the meters in the specific case that are currently deployed in the network. We have the ability to filter on all kinds of statuses. We can basically filter only on the inactive devices, or we can filter on the current active devices. We can filter on specific device names, on area, and so forth. So we have ability to narrow down the area of interest in the network to more easily do fault detection. Considering the network architecture that we discussed previously and how the data flows, we can deploy from our platform gateways and also nodes. So gateway deployment works fairly straightforward. Again, you have the ability to bulk import files in a CSV and then do a type of quality assessment and send the gateways to the deployment page. So once a gateway lands in the deployment page, we can check that there's a connectivity with the gateway and underlying infrastructure, and then you can install it, and then finally it will end up in a monitor page where you can see whether it's active or inactive. Here, bulk import is of course very important because we are talking about tens of thousands of nodes in the network, and from this point of view, it's then important that we can have the flexibility to deploy multiple nodes at once. So again, you can import the file using a CSV file, then you perform the internal quality assurance test, basically making sure that the devices were delivered in the correct way. And you can select all of the devices that you want to import. You can send them to deployment. And here you would check the devices until they're connected. So we are currently busy with a simulation, so these devices are on purpose not connected, but once they are connected and connection is up and running, we know that the devices have connectivity to the LoRa network, and here we can then install the devices. As soon as the devices have been installed, they will show up in the node monitoring page, and then you can have the ability to look in individual meters or devices to see, for example, what was the last energy consumption in this case for heating meters. We also have the ability to trace how the deployment page followed. So this is also a good way of having visibility on an individual device level. Here you of course can also filter on inactive and active devices. So there's a lot of flexibility here. Then another important aspect is alerting. So we have the ability to configure alerts on different levels. We can either configure alerts on a device level, whether they are online or offline. So here a good example is when a gateway goes offline, it means that a lot of devices in its region will not be able to send their values. So here it's important to detect proactively when a gateway goes offline. We can also look into individual devices and look at alerts triggered by temperature changes or actual measurements that exceed certain thresholds. So when an alert is triggered, you will see it here in the monitoring page, and it can either be manually resolved, or if the temperature again, for example, drops back to normal, or the gateway comes online again, then the alert will automatically be resolved. And all the critical alerts are shown here.
Good. Thank you very much, Vera. So just to recap a couple of the main features of our platform. So an important point to stress here is that we enable simple and scalable rollout of large devices, because we are talking here of devices in excess of 50 or easily 10 to 100,000 different nodes. And this needs to be done in an organizational specific way. So it needs to be integrated with existing devices. So the rollout process is really important. And here we would typically use a mobile application to assist with the rollout process. Of course, we also have the ability to effectively manage the LoRa network and all the underlying infrastructure, so that we can quite easily and proactively detect faults. And then, of course, the downstream system integrations would be very interesting for the target audience here. And we do work on providing a HAKOM PowerTSM integration here, so that we can basically get out of this data jungle, as Stefan already mentioned. Security is, as always, important. This is not done as an afterthought. We have role-based access that is based on the principle of least privileges. So our platform is indeed quite flexible. Stefan, if you could please move on to the next slide. So one thing that I did not mention yet is that the problem with rolling out all of this infrastructure for a single use case is that the business case is always not that great. So if you really roll out all of this LoRa infrastructure just to do remote meter reading, the business case sometimes becomes difficult. But to basically improve your return on investment, there are a lot of other additional use cases that you can cover using LoRaWAN. So I'm not going to go through all of them. It should be fairly self-explanatory, but the one thing that I do want to stress is that we can improve district heating network infrastructure. So that is basically adding additional sensors that can communicate over LoRaWAN, and there you can measure temperature, pressure, and leakages can quite easily be detected by these sensors. So in general, this is a good supplement to existing SCADA networks. Stefan, if you can please move on to the next slide. So it's time to just make a couple of conclusions. So we've seen today that enabling remote heating and water meter is a high priority for the EU. And LoRaWAN is indeed a very appropriate technology for this. However, utility companies are really struggling with the complexity of deploying such a large system. This is not very simple. And also the basic business case for LoRaWAN is often difficult if you have only a single use case that you try to cover with LoRaWAN. But as soon as you have this base infrastructure available, the return on investment really starts to pay off. Lastly, connecting all the data coming from LoRaWAN to your IT raises all kinds of new potential, and therefore connectivity is really, really crucial. Thanks a lot for giving me this opportunity. Stefan, please back to you.
Thanks so much, Reinier. Thank you very much for your insights into management of the assets, monitoring and integrating them into the OT environment. Having your system architecture in mind, let's now somehow change the perspective and have a look at the IT part. So Thomas, how do we integrate IT now? And first of all, why should we do that?
Stefan, that's a good question. And the answer is simple. It's not only about monitoring and maintaining the devices. We need to make use of the data they produce. In the particular use case Reinier was talking about, the consumption data will be used for billing purposes. And that is clearly not the issue of an OT environment. So we need to transfer the data to the IT environment. Typically, the sequence of time series data processing starts here. We have to identify implausible data, outliers, or missing data. When data is being relocated and changed, we need to be able to track changes. So we want to be able to travel back in time to see what data has been replaced. And then, of course, in many cases, data needs to be aggregated. For example, forecasting consumption or production for certain regions. And the next thing would be to harmonize the data from the sensors with other data that reside in your time series data storage. All in all, we need to ingest the data, make it available in data warehouse quality, and connect it with other data that is spread all across your organization. And for all of this, a purpose-built API should be available. And that is exactly how we designed the PowerTSM API. But now let us talk about how to create the connectivity. Connectivity counts. So we tailor-made a program for all interested vendors to create a connector to our PowerTSM platform. We start with a special proof of value program that focuses on connectivity. It fits a great range of use cases and includes the whole process mentioned before: validate, ingest, and process. At this stage, it is important to include all relevant teammates: the business case owner, the use case owner, and the solution architect. Together with an experienced solution architect, usually I will moderate the workshop. Within hours, we show how to create connectivity for any service or application. We have done a lot of POV programs up to now, and we are extremely happy how efficient this is. After this, partner will still have access to our API, to the developer support, and our comprehensive documentation repository. We just ask the partner to develop an item for the store within the next 12 months. We believe that's fair enough. Creating a connector that way really is as easy as ABC. So with that said and promised, let's start our call to action.
We have seen how to easily connect to services providing data coming from different sources in the PowerTSM Store. The whole process is really simple. For all our PowerTSM users, we created an easy way to get access to services and connectors, and applications will be available soon. Simply click on Store and filter what you're interested in. Go for Services and check the details of the featured service. If you want more details, you can have a look at the pricing and contact the vendor to find out more. The store is non-transactable. This means that you will sign a contract with the service provider according to his terms of use. By means of our connectivity program, we make sure that the service runs smoothly. We will start with our first services right now, so log into the portal and check it out. A community will not work without its members. Therefore, I would like to ask you to support us. Give us your feedback on what kind of connectivity you need. What kind of data would you like to see? Which systems or organizations are important for you? Which services or data would you like to access? If you are a service provider and want to publish your service in our store, again, just contact us. You can reach us at sales@hakom.at or directly on LinkedIn. Or, of course, right now, because it's time for the Q&A. So once again, back to you, Stefan. Thank you to my digital twin once more. As announced for our Q&A session, we will be now available for your questions, so start shooting. Just for information, after the official part of the webinar, we will stay for another 10 to 15 minutes. So let's start with one question. I would put that to Reinier. Oh no, better maybe to Thomas, because it's regarding PowerTSM. Can PowerTSM connect to any service in energy? Do you think, Thomas, that makes sense?
Yes, basically, it only makes sense for services and apps that require time series data. For example, providing public available time series data such as meteorological data or prices or power plant schedules. In the case of complex apps, it's not always possible to get all time series into PowerTSM. Here we take the opposite approach. The connector then is available in the partners app that gets time series data directly from PowerTSM. All of this happens based on our API, ensuring performance and security.
Thank you. One goes out to Reinier. Are there alternatives to LoRaWAN, MIOTY, or MIOTY, wireless M-bus and such?
Yes, so they are not necessarily always competing technologies. So I would say LoRaWAN, for specifically the use case of remote meter reading, is in my opinion still the best one. But there are up and coming technologies, and I think one that are looking currently quite promising is MIOTY. This comes from Germany, and a lot of studies has been done that apparently shows that it's very robust. So I think it's still not as mature compared to LoRaWAN, but it definitely looks quite promising. Then, of course, wireless M-bus is also a natural choice. So I've heard a couple of energy providers that supplement the LoRaWAN with wireless M-bus, maybe to reach the last couple of meters that are difficult to reach. So yes, there are definitely alternatives, but I think LoRaWAN is still the most widely used, and the ecosystem is also, I would say, the best.
Thank you. Another one for you, or maybe for both of you, but let's start with you, Reinier. What aspects are often underestimated? What would be the showstoppers from your experience?
Underestimated. I think you would think such a system is quite simple. You know, if you want to build a quick proof of concept and you fire up a Docker container and you use some meter with a LoRa device, it's quite easy to get the data from the meter into some Grafana dashboard or whatever. But really, if you want to do this in a scalable way, that is still high performance, that is of course quite difficult. And then, of course, more of an organizational topic is the silo concept that you often find in energy providers, where you have a lot of different departments that have to work together to roll out the solution. But the communication between these silos are often not very, very good, the communication between the different teams. And then often some things fall through the cracks.
Mm-hmm. Yes.
So these are two of the things that often are quite underestimated.
I think we can add to this, talking about the IT part of the integration and this energy data jungle on IT side. What really helps a lot is if you have a sound and proven method of integration, and if you can publish an API like ours and make it available to others, then you can, connect those silos quite fast. And if you see all of a sudden that you miss one piece of the puzzle, then you can onboard this one much faster than to having starting from scratch with new formats and new APIs and things like this. Yes, to Thomas, talking about the workshops, what are lessons learned in the workshops? What's your experience? Done quite a lot.
Yes, quite a lot. But one that fits for everyone is the best way is just to start with the easy parts and then add complexity later on, so that you have a quick start and can integrate different sources and different kinds of time series, so that you can start quickly and later on then gradually add more complexity. So that's a good way to start with it.
Keep it simple for the start and create some usage. What are the IoT devices deployed in your LoRaWAN? Reinier, you already took over.
Yes, so I would say this is again somewhat dependent on the actual use case that you're trying to solve. There are multiple numbers, so we are not limiting ourselves to any specific IoT devices. We can support any type of LoRaWAN device, but to answer your question more concretely, we have some devices that do simple temperature measurements, humidity measurements. You have sensors that detect certain events. So, for example, when a door opens or a door closes, we have sensors that you can use to measure pressure. That's relevant also for heating networks and for water networks, where you can measure pressure, where you can do leak detection. And then for other use cases, we can have sensors that you put underneath a parking space to detect when the parking space is currently occupied. So the opportunities are quite endless, and we have a generic way of integrating new sensors into our platform. But again, it's very use case specific.
Perfect. I see two questions about security. One is quite general, how about security? Other one is data security is one of the main concerns, obviously. Which communication system offers the best cybersecurity? I mean, best is always a good question, but how about your experiences?
I think let's first do the first security question. I would say the security is maybe sometimes even a bit of an overkill of the data security, but you can't underestimate it. So LoRa in the specification provides end-to-end encryption. That means from the sensor all the way to the network server, there is end-to-end connection encryption, and then also you have security between the gateways and the LoRa network, LoRa network server. And there we can use SSL and TLS type of certificates. And then additionally, at one of our customers' sites, where they use a GSM or LTE as the backhaul interface, they would also configure IPsec tunnel for providing security. But of course, that is just getting the sensor measurements into it, and then the actual security is largely dependent on where the system is hosted. So if we have an on-premise system, which is a couple of our customers so far, then it's very much dependent on what the customer and energy provider has.
Okay. Yes, in terms of communication system, maybe I have to add something, general question about security and authenticity. We did a webinar on that, it was some months ago, so you can check it out on our YouTube channel. Quite interesting because we use our data flag concept in order to flag or tag data that has been authenticated. So I really can recommend to have a look at that video. Yes, there's a question regarding organization. If PowerTSM is a subsidiary of HAKOM, no, HAKOM is, we are the vendor, HAKOM Time Series, we are the vendor and provider of PowerTSM. PowerTSM is our platform and service that we provide to vendors and energy service companies to store and process their time series data. I think we lost Reinier for shortly. He's back again. Very good. Yes, the general one, how is connectivity established between OT and IT? Reinier, would you like to share some thoughts?
So I think he refers to the question, the interface between our platform and then downstream services, if I understand correct. So there we have different ways that we can provide the meter readings or the sensor measurements and so on. And this again is somewhat specific to the customer. But what we have more or less out of the box is a REST API that we can integrate with downstream existing services. And we also have MQTT as an interface, because that's quite a common use for IoT type of data. But we are quite flexible, and from our point of view, we are a vertical solution. So we are not married to any single technology or interface or whatever. So we are really focused on solving the problem with whatever the best tools for the job is. That is our approach.
Thank you, Reinier. With respect to time, we are already a bit over time. So I suggest there are still some questions open. So please, if you have some time, stay. We will be there and answer. But we will now close the official part of our webinar. And like last time, we will send out a short email right now. And it will contain a link to a LinkedIn post where you can continue asking your questions. And please join in for some lively discussions and thus stay in touch with us. For those who do not stay and we have to say goodbye to, have a great springtime. Stay tuned to us and subscribe to our next webinar on incentives for energy efficiency, which will be in May 2025. And finally, don't forget, life is a time series. So back again, because we still have some open questions. There has been one regarding the EDA portal. I think, Thomas, you have to you have some information on that.
Yes, right. We have an R&D project in place where we established a connection to the EDA portal, and it's possible to get the data from the EDA portal direct to the PowerTSM. That's now in a test phase, and within the next month, this also would be available for customers if they like to use this connection. And then the connection is established via a gateway that also is capable of connecting to other international portals. So there's not only the EDA, the Austrian EDA portal, but in future there will be connections to other similar portals.
Perfect. One interesting question: how can we contribute to HAKOM Time Series? Do you have any work or job opportunities? Yes, we quite often looking for new stuff, and just apply. But if you already work for a vendor, then you could also, as a vendor, contact us, and we are very happy to start this this connectivity program so that you will be able to use our technology to connect, and then yes, we can exchange data and help to fight the energy data jungle together. And the last one is, will you provide any certificate for attending the webinar? We can provide some kind of this confirmation, if you like, if that is useful for whatever. We are happy to do that. So just contact us right afterwards. We are happy to help you. I think now we have covered basically all of it. So again, thank you for joining. Please stay tuned to us, and don't forget, life is a time series. Bye-bye, and thank you.
Bye.
Bye, Reinier.
Thank you very much.
Bye.